Last year, the Lahaina fire in Maui killed over 100 people. The official emergency alert went out after the fire had already destroyed most of the town. That's not an anomaly. That's how most wildfire alert systems work: slow, manual, dependent on someone noticing and filing a report. Signet does something different. It watches constantly, from space, and it doesn't need anyone to notice first. Signet is an autonomous wildfire tracking system that pulls data from satellites and weather feeds, detects active fires, and surfaces that information in real time at Signet.watch. No login, no paywall, no waiting for a government agency to update their portal. You open the map, you see what's burning right now. Here's how it actually works. Signet ingests thermal imaging from NASA's FIRM system, that's Fire Information for Resource Management System, which captures heat signatures from satellites like MODIS and wires passing over the Earth multiple times a day. Every time one of those satellites crosses a region, it's scanning for thermal anomalies. Signet takes that raw data and layers it with weather information: wind speed, wind direction, humidity, temperature. That combination matters because a fire in dry 40 miles per hour winds behaves completely differently than the same fire in calm humid air. The system isn't just marking a dot on a map. It's building context around each detection. On the interface, you get active fire perimeters, hotspot clusters, and the direction those fires are likely to spread based on current wind vectors. The data refreshes automatically as new satellite passes come in. There's no human in the loop deciding what gets displayed. That's the autonomous part. It's not waiting for a ranger to call it in. What surprised me was the latency. Satellite passes happen every few hours depending on the orbit, and Signet surfaces detections within minutes of that data becoming available. Compare that to some county alert systems where the lag between detection and public notification can be measured in hours. For fast-moving fires, that gap is the difference between evacuation and being trapped. But here's the thing: Signet is not a replacement for emergency services, and it's honest about that. It doesn't send push notifications to your phone. It doesn't integrate with 911 or local emergency management systems. If you're not actively checking the website, you won't know about a fire near you. That's a real limitation. The system is pull, not push. You have to go to it. It also can't distinguish between a wildfire and a controlled burn without additional context, which means you may see detections that are intentional agricultural fires or prescribed burns. The thermal signature looks the same from orbit. The satellite data itself has resolution limits. MODIS detects fire areas down to about 1 kilometer squared. VIRES improves that to roughly 375 meters. That's good enough to track a large fire front, but it means a small ignition in early stages might not register until it's already grown. Early detection of the very first spark, that's still a gap. And coverage isn't uniform globally. Satellite revisit times vary by latitude, and some regions get fewer passes per day than others. In high-risk zones like California or Australia during fire season, coverage is good. In less monitored regions, the picture can be patchy. Now, what could this realistically become? The architecture is already set up for expansion. Adding SMS or webhook-based alerts tied to a user's geographic area of interest would fundamentally change how useful this is for individuals and local governments. Instead of a map you check, it becomes a system that reaches out to you. That's not speculative, it's a straightforward engineering addition on top of what already exists. A second realistic path is integration with fire behavior models. Tools like Farsight or Phoenix already simulate how fires spread based on terrain and fuel load. If Signet's real-time detections fed into one of those models automatically, you'd get not just where the fire is, but a probabilistic map of where it's going in the next 6 to 12 hours. That kind of output is what incident commanders actually need. There's also a data archival angle. Every detection gets timestamped and geolocated. Over time, that's a dataset showing ignition patterns, spread rates, and seasonal behavior by region. Researchers, insurance companies, and urban planners are all potential users of that historical layer. So why does Signet exist? Because the alternative is genuinely bad. Government wildfire portals are often updated manually. CAL FIRE's public map, for example, is useful but has known delays. Private services that offer faster data usually sit behind enterprise contracts. They're built for utility companies and government agencies, not the person who lives at the end of a rural road and wants to know if they need to load their car tonight. Signet is open. It's built on public satellite data that NASA and NOAA make freely available. The developer took that data and made it actually accessible, fast, visual, and requiring zero technical knowledge to interpret. That's the real contribution here. The data existed. The gap was in surfacing it for anyone who needs it. Wildfires are getting worse. The seasons are longer. The fires are bigger. The window to evacuate safely is getting shorter. Any system that compresses the time between ignition and awareness is worth taking seriously. Signet is early, it has gaps, but what it does work, it works right now, it's free, and it doesn't require you to trust that someone else already noticed. Next episode, we're looking at an AI tool that monitors power grid anomalies before outages happen. Same philosophy, completely different infrastructure. Subscribe so you don't miss it.